Alright, hi guys, it is Miss Davis. Today we'll be going over acids and bases. Very basic acids and bases. If you decide to take AP Chemistry or you take chemistry in college, you will go way more in depth than this, but this will just give you a good foundation for it for when we get there. Your bell work question for today: what type of reaction is nickel plus tin sulfate if it yields nickel sulfate plus tin? Don't worry about balancing the the equation. It's already done for you. We will go more over this a little bit more on Monday. I'll do another presentation just to kind of drive home. Mr. Smith said that you guys were struggling with this a little bit, but just remember awkward prom scenarios. Okay, so person 1 goes to prom by themselves. Persons 2 and 3 go together. So the tin and the sulfate, they're going together. By the end of the night, tin and sulfate decide they don't want to leave together, but nickel and sulfate, so now persons 1 and 3 are together, and person 2 leaves by themselves. So you have one switch out is basically what this is. So if you have a single switch out or a single replacing, you have single displacement or single replacement. Okay. Again, we'll go over that a little bit more on Monday when you get your review guide. Alright, so first thing we're going to do is go over the characteristics of acids. Acids are going to be anything from 0 to 6.9 on the pH scale. If you get to 7, remember the 7 is neutral. So pure water is going to be a 7, and that means it's nothing but H2O. It's distilled. Tap water is actually slightly acidic. Very slightly acidic. Okay. So keep those in mind. If you taste an acid, it'll taste more sour. So things like lemons, limes, even soda is slightly acidic. So technically what an acid is it's a hydrogen ion donor. So anytime for this class that we have an acid, it'll be hydrogen plus a non-metal. So let's take, for example, hydrochloric acid, which is HCl. So it's a hydrogen ion or H plus donor, so that means that this hydrogen here will actually leave and go to the base as it's reacting. So anytime you give up that hydrogen, you're technically an acid. That'll be more important when we get into, or when you get into more complicated acid-base chemistry. And again, acids are going to be that hydrogen ion, that H, plus some sort of non-metal. Just make sure that your equations are always balanced. So if your non-metal has a charge of positive or of -2, make sure you give it 2 hydrogens. Okay, so as is the case, the example here with sulfuric acid. Okay, so because sulfate has a charge of +2, you have to have 2 hydrogens. Common acids are going to be things like lemon juice, that's technically citric acid, vinegar, like I said, soda, even your saliva has a slight acidic charge to it. Bases are going to be basically opposite of acids. So they're going to be a 7.1 to 14 on the pH scale. Again, remember 7 is neutral, that means it's pure water. But these are going to be things like Drano, bleach, baking soda, things like that. Okay, if you were to taste bases, most of them will taste bitter, and they're actually more slippery. So things like soap are going to be basic. When the acid donates that hydrogen ion, bases are going to take that hydrogen ion, and we'll discuss what they do with that later and what that makes it look like in the product side of the equation. What a base is for this class, it's going to be an alkali metal or an alkaline earth metal, so that's groups 1 and 2 on your periodic table, plus this OH, it's called a hydroxide ion. And one thing I need to mention is that the hydroxide ion is a charge of -1. So NaOH, sodium hydroxide, MgOH2, magnesium hydroxide. Okay, and here are some common bases. Okay. So here are some examples. I want you guys to try to determine if this is going to be an acid or a base. So you need to pause the video, try this out, and then when you hit play, you will be able to check your answers. Alright, so hopefully you guys got the following answers. So if it's a pH of 3, that's an acid. If it's AlOH, is that hydroxide ion, so that's a base. Zinc hydroxide is a base. If it's got a pH of 9.7 or 7.1, those are both above 7, so those are bases. And then HF, because it's got that hydrogen ion, that's going to be acidic. When it comes to naming acids and bases, naming the acids is the most complicated part, and it all goes back to if the anion is a polyatomic ion or if it's just an anion. Okay. If it is not polyatomic, so it's just your basic anion, then you're going to use this first way to name it. So for example, if we go with this, our first example here of HF, because the F is not, the fluorine is not polyatomic, we would call this hydrofluoric acid. Okay. So same with the second one, because you have the hydrogen ion, okay, and then whatever follows that, that's going to be what determines how you name it. So this S, the sulfur, because again it's not polyatomic, so this would be like sulfide. You're going to use this first way to name it. Okay, so we're going to call this one hydrosulfuric acid. Okay. Now, if your acid is polyatomic, it kind of depends on what type of polyatomic ion it is. If it's one that ends in ite, so for example sulfite, you're going to name this with the ending OUS. So this would be sulfurous acid, as opposed to sulfuric acid, which would be the case if your anion ending is ATE or 8. Okay, so that's how you determine the difference between if it's like HSO3 or HSO4 based on the name. So if you have H2, so here's your hydrogen ion, and then you have CO3, so there's our polyatomic, and this is carbonate. Okay, so if it's carbonate, we're going to name this with the IC ending, so this is carbonic acid. Okay. Bases, way more easier. They're going to just be the cation plus the ending hydroxide. So for example, if our cation is sodium, here's our hydroxide ion. This is literally sodium hydroxide. If our cation is magnesium, here's our hydroxide ending. This would be magnesium hydroxide. And I'm just going to abbreviate so that I can keep going here. If you need more on how to name acids and bases, Khan Academy has a pretty good video. Here, buddy. Khan Academy has a pretty good video, as does Bozeman Science. So, and you can just honestly Google it, and it'll give you mounds of videos. Okay, so, more examples. I want you to name. So a name would be something like these here. So if you get the formula, I want you to name it. If they give you the name, I want you to write the formula for these examples. So pause the video, try it. When you hit play, you can check your answers. Alright, so checking our answers here. If you have H2CO3, that's carbonic acid. Chlorous acid is going to be HClO3. Barium hydroxide is BaOH2. Beryllium hydroxide, BeOH2. Hydrosulfuric acid, H2S, and nitric acid is HNO2. So I want you guys to do a quick write. How can you determine the difference between an acid and a base? Pause the video. I want you to compare answers. I want you guys to discuss, and then we'll keep going. Alright, so when we are combining acids and bases, for this class you will always get H2O and some sort of salt as your product, okay? And I actually have that twice. And so this is where the hydrogen ion from the acid gets donated to the hydroxide, okay? And so if it's HOH, that is the exact same thing as H2O. And then your other reactants will come together to create some sort of halide salt. Okay, so just a salt with a halide in it. And your end result will be neutral, so the pH will be 7. Okay. Now the other thing that happens is when you have acids and bases coming together, you're going to create what are called conjugate pairs. And basically what that means is it's kind of like the siblings on both sides of the yield arrow. Hey, buddy. You want that? No? Okay. So for example, when the reactant acid, so when acid 1 loses its hydrogen, it's going to create the conjugate base in the product. Okay. So here's our acid 1. The conjugate base for the HCl is actually going to be the NaCl. Okay, so that's the conjugate base of the first acid. When the reactant base gains the hydrogen ion, okay, that's going to create what's called the conjugate acid in the product. And so that's going to be, for this case, it's going to be the water. Okay, so that's our conjugate acid. If you ever see something that ends perfectly like this with water and some sort of salt, the water will always be the conjugate acid. The salt will always be the conjugate base. Alright, so your homework for this lesson, I want you to actually keep these in your notebook. And then I will provide the answers to Mr. Smith, so you guys will actually check and go over these on Monday. Then you will get your review guides. You will go over how to identify reaction types, and go a little bit over, we'll go over that again. And then you have a test next Wednesday. If you have questions, make sure you YouTube, Google it. I'm not very good at answering email right now just because of this little guy, so your best bet would be to seek out answers for yourself first and then ask Miss Sekle. She is available for you to use. Just make sure you guys are taking initiative to find the answers, and yeah, good luck, happy studying, and we'll continue this on Monday.